Hi everyone. Previous video we looked at the definition of a complex number, how all real numbers are complex numbers with the imaginary part being 0, how we can talk about real part and imaginary part of complex numbers. Now we're going to look at some algebra. The first obvious thing is how do we add and subtract. So this is the same method that we've been doing with polynomials and radicals. Okay, so meaning like terms combine. So we can straight up go into an example here. Example, if I have 2 plus 3i plus 1 plus 5i, right? What I'm going to do is I'm going to collect the real part. So 2 plus 1 plus 3 plus 5i. So this becomes 3 plus 8i. So it says you add, subtract the real part and you add, subtract the imaginary part. Okay, so same example, if you were subtracting 2 plus 3i minus 1 plus 5i, so this is going to be 2 minus 1, that's the real part, and 3 minus 5, which is the imaginary part. So you would get 1 minus 2i. Another way to do this is, or you can just write this down as 3i minus 1 minus 5i, and then 2 minus 1 is 1, and 3i minus 5i is 1 minus 2i. So addition and subtraction, it kind of follows the process that we had for radicals, right? Which makes sense if you think about it, because what is I? I is really a radical. It's a radical of a negative number, which means the same properties that were enjoyed by radicals is going to be enjoyed also by I. It's going to have the same properties. It's going to take advantage of all of those properties. The next one is multiply. Now, multiplication also follows a similar process as radical or polynomial. Namely, what do you do when you multiply two terms? You distribute, right? Now, the only difference here is when you distribute, you are going to end up with powers of I. So it makes sense to look at what these powers of I mean. Okay, so let's see, what is I squared? So recall, we all started with this definition that I squared plus 1 is 0, or I squared is negative 1, which means that I squared can be replaced by negative 1, which is really useful because that means that I squared is actually a real number. It's just negative 1. So wherever you have I squared, that just means a multiplication by negative 1. Now, what is I cubed? Using by exponent law, which is that when you multiply the exponents add, you get I cubed is I squared times I. But what is I squared? We just found out I squared is negative 1. So this is negative 1 times I. So this is negative I, which is also really cool because it means that even if I have a higher power of I, like I cube, when I distribute and some sort of multiplication ends up with that, it's not a new number. It's still just negative of I. Now, using the same process, again, by exponent law, I to the 4 can be written as, it can be written as I cubed times I, right? Which would make this negative I times I, which would make it negative I squared, which would make it negative of negative 1, which is 1. Or I to the 4 can also be written as I squared squared, and I squared from this line is negative 1 squared is 1. And then I5 is I to the 4 times I, but that's 1. So it comes back to becoming I, right? So this means these powers, they cycle. So you start with I, then you go to -1, then you go to negative I, then you go to 1, and then you switch back to I. So they have this very nice pattern that higher powers of I just keep repeating. Okay, so the way to put that is I to the power 1 is I to the power 2 is -1, I to the power 3 is negative I to the 4 is 1, and then back. So this would be I to the 5, this would be I to the 6, I to the 7, I to the 8. Then this would be I to the 9, and so on. So for example, if I asked, what is I to the power 2021, right? All you need to figure out is where in this chain does this occur. So what you do is you do 2021 over 4 and you find the remainder. Now 2020 being a leap year was divisible by 4. So the remainder here is 1. If the remainder is 1, then it equals I to the 1, which is I. If the remainder is 0, then it equals I to the 4, which is 1. Right? Because if it's divisible by 4, that means it's I to the some fourth power, so it is 1. Then if the remainder is 1, then it's I to the 1. If the remainder is 2, it's I to the 2. If remainder is 3, it's I to the 3. And you can't have a remainder of 4 because that basically means a remainder of 0. So this gives us a way in which all powers of I can be expressed simply in terms of, ones and i's, which is again very nice because it's not requiring me to introduce any new number. All of this is done just by introducing one new number, which was I to begin with. So now let's look at an example of multiplication, right? How do we use this? So if you have 2 plus 3i times 1 minus I. Let me move this down here. And move this a little down further. Okay. So just as with polynomial, we are going to FOIL, right? When you FOIL, you multiply this 2 with this, and you multiply the 3i. So you're going to end up with 4 terms. And the 4 terms that you end up with are 2 times 1 plus 2 times negative I plus 3i times 1 plus 3i times negative I. Okay, every term has to multiply with every other term. Now the first one, this is a real number times a real number. We know how to do that. That is 2. The second one is a real number times I. So this is just 2i. The third one is also 3i times 1. So this is just 3i. The last one, there's a negative. So this is negative 3. And there are 2 copies of I. So that becomes I squared. However, in the next step, I'm going to use the fact that we know the value of I squared, right? I squared is actually -1. So what we have here is 2. Now these can be combined. -2i plus 3i is just I. And this is -3 times -1. So this is 2 plus I plus 3, which is 5 plus I. So multiplying these numbers give me another complex number. So this is a complex number which has real part 5 and imaginary part 1. Let's look at another example. Let's give these coefficients. So let's make this 2 plus 3i and 3 minus 2i. So I have a 2 times 3. So let me write it down. 2 times 3, 2 times -2i, 3 times 3i, 3i times negative 2i, that's a 6, that's negative 4i, that's 9i, and that's negative 6i squared. So you have 6, negative 4i plus 5i plus 9i, sorry, is 5i, minus 6 times negative 1, so this is 6 plus 5i plus 6, which is 12 plus 5i. Now one thing to note here is each time we are multiplying a complex number with another complex number, we end up with a complex number, right? This is going to motivate the next section, the next video, which is division. This means that if I take this complex number and I divide it by this complex number, I should get the first one. Think of it in terms of the regular real numbers. If 2 times 5 is 10, then that means 10 over 5 is 2 and 10 over 2 is 5. So if 2 plus 3i times 3 minus 2i is 12 plus 5i, then it must be so that 12 plus 5i divided by 3 minus 2i, for example, is 2 plus 3i. Which motivates us to think about the fact that division is also possible, right? It means that if I divide two complex numbers, I am going to get another complex number. What remains to be found is how do we do this division so that we end up with a complex number. And that is something we will learn in the next video. And as you can see here in the notes, it's going to make use of an old technique that we have used a bunch of times, particularly when working with radicals, right, which is the process of rationalization. So in this case, we will be focusing on rationalizing the denominator using similar ideas that we have seen in the radical section of the course. Okay, that's it for this video. The next video we will look at division of complex numbers.